Hi everyone, today we're going to look at how to solve a linear system graphically. This will involve plotting two lines that are in the form y equals mx plus b onto the same grid and then looking for the point where they cross each other. We can begin with the first line of y equals 2x plus 1 and graph this on the first grid. We will start at a y-intercept of 1, and then from there we will count a rise of 2 and a run of 1, remembering that when a coefficient doesn't have a denominator, we know automatically that it is a 1, and so in this case, our slope will have a rise of 2 and a run of 1. We'll repeatedly count this slope over and over again until we run out of space on our grid, and we can follow the pattern in the other direction as well so that we can see the line taking up as much of the grid as possible. Our second line will begin at -2 as our y-intercept, and then we will count up 3 and over 1 for the run, up 3 for the rise, and over 1 repeatedly. And then again, we can repeat that pattern in the opposite direction so that we can fill up as much of the grid as possible. We can see that when we draw our lines through these sets of points that they do cross each other at a point that's labeled in purple at 3, 7. So this is our point of intersection. Notice that it has both an x and a y coordinate within it. For our second example, we'll begin by plotting our first line at the y-intercept of -2, and then we will count down 1 over 1 repeatedly, and in the opposite direction following the same pattern. Our second line will begin at +7 for the y-intercept or b value. And then as we count up 2 and over 1, we'll find that we're going off of the grid. So we'll need to repeat that grid pattern and follow that grid pattern down in the other direction until we find the place where the lines cross each other. As we draw our lines through all of the points, we can see that in this case there's a point of intersection of -3, 1. In our third example, we'll start plotting the first line at +1 for the y-intercept, and we'll go up 2 over 1 repeatedly until we run out of space on the grid. We'll do the same for the second line, beginning at -3, and then plotting up 4 for the rise and over 1 for the run. We'll repeat this count until we run out of grid space, and we'll see that there's a point of intersection when the lines are drawn at the location 2, 5. In our final example, the first line looks a little bit different. We have a y equals -4 equation here. Remembering that when we see an equation like this where it's a variable equals a number, that's a special case. And in this case, as a y equals line, we'll know that this is a horizontal line. So we will plot our y-intercept at -4 and draw a horizontal line through that point. We'll go on to plot our second line by starting at +2 and then counting our rise of -3 and over 1 repeatedly until we find the point of intersection. This point of intersection occurs at 2, -4. So that's how we find the point of intersection, by plotting lines on the same grid in order to find the place where they meet. This is how we solve a system of linear equations.